Hello, I would be talking today about AWS Lambda and how it mixes together with Scala. And you have here, my name is Pawel Dolega. You have my Twitter handle here. I work at Virtus Lab. Well, I guess I'm no one particularly important, so I just skip to the, I just start the talking about the AWS Lambda. So as for the expectations that I wanted to make kind of for this presentation is that I really do understand that these days the AWS Lambda being, well, part of the serverless movement, approach, whatever, it's like these days it's kind of real buzzwords, right? So everyone is talking about the serverless. It's like a couple of years ago we had those conversations on every other conference. There was a presentation about microservices, et cetera, et cetera. So serverless seems to be that kind of a buzzword. So what I'm trying to avoid here is I'm not going to sell you this buzzword bingo that serverless is going to help you save the humanity or make your projects better. In fact, what I'm thinking is that I would be pretty cautious with adopting, production-ready AWS Lambda components in your products, especially if you are using Java. So the kind of a goal of this presentation is not to encourage you to that. What I would be trying to encourage you is to give it a try. Perhaps pick something small in your infrastructure, in your product, ideally that is event-driven, and just try it out how it works. What is serverless? Because I guess we need to start with that before we would talk about AWS Lambda in particular. So that is a little bit confusing because serverless on one hand is the term used for the general movement, on the other hand is used for the approach or for the technique that you can use. Here is one of the definitions that I found in the book Serverless Architecture on AWS by Peter Zbarsky. So I think that the important part here is it's a set of hosted services and a self-managing infrastructure. How you can look at this from the other perspective is that it's kind of an attempt to allow you to abstract over certain aspects of the infrastructure and focus yourself primarily on the code that you are delivering, the code that is to give you the business value of the product. So it's not like that's another thing, it's not like the serverless means that we have no servers or that there are less servers. What it means is that basically the infrastructure of the server is someone else's problem. In that case, it is the domain of Amazon to give you the infrastructure that you can leverage. So one way of thinking about this is that whenever you have a complexity, the complexity of the product is basically composed of two things. At least of these two things. One is this essential complexity, which is basically what is the core business of your application, and then then you have the accidental complexity, which is everything that is not really related to what you need to do from the business perspective, but you need to do it anyway. I give you an example. So this may be if you've been working in banking industry, and when you do, for instance, the software for trading options. Obviously, trading options is your core domain. But to do that, you need to also think about things like scalability, perhaps, because you have big load, the high load of the high volume of the request. You have to think about resilience, and you have to think about, I don't know, dealing with time, encodings, etc., etc. This is all accidental complexity. So the idea behind, that clicker doesn't really work as I planned. The idea behind the serverless is that you should be able to focus more on your business domain or your core complexity of your software, essential complexity, and perhaps less on the accidental complexity, especially related to various aspects of the infrastructure, right? Because if you think about that, there are many, many different things that are part of the complexity that we need to deal with any other project, right, over and over again. So this approach is kind of the attempt to maybe not to eliminate this complexity, but at least help you on some level with some of those things. So yeah, basically focus more on the core business. What is the characteristics of the serverless and Lambda in particular? Well, there might be perhaps three predominant characteristics. One is that it's stateless. The other is event-driven, and then at the end is the computational part of your software. So as for the statelessness, so well, perhaps it would be beneficial to look at. I'm not sure if that's visible. If it would be beneficial to look at how the Lambda is being, at least on the conceptual level, how it's built. So if you think about that, like, I don't know, 20 years ago, we were dealing with bare metal servers, right? So we had the boxes in our companies, and we were having most of the applications running there. Perhaps 15 years ago or something like that, there started to be cloud products started to be popular, and we moved to EC2, which basically allowed you to not have the physical box, but you still needed to deal with the operating system, etc., etc. And I think last 10 years, which is basically the appearance of things like namespaces, C groups, LXC, so the containerization, and on top of that, products like Docker, which wrap all those things together, allowed us to have containers. So Lambda is basically this layer. It's a computational code that is run within container, and this container is fired somewhere on EC2 instances. All right. Let's think about, again, conceptually, how the flow of the requests and the life cycle of such a container may look like. So let's assume that we have some kind of a user invokes our logic, and two things may happen. First, the container may not be started, may not be bootstrapped. So that's this path. If it is bootstrapped, well, that's easy. We just invoke our handler, our code, and it processes the request and replies with some response. However, if it's not started, what we need to do is bootstrap the container, and when it's all loaded, which may be time-consuming, especially with Java, when we need to load everything, we can finally pass the control to our handler here and return the result. This is actually relatively, I mean, that is a simplistic view of how it works, because it's not only about whether the container is already bootstrapped or not. If we think about that part, it's different things may actually happen. So why our container may not be reused? So this is the first thing. Well, the container is not existent. So it either crashed or it haven't started yet. So we need to start the container with our logic. But, and that's interesting thing, it may happen, and this is our second point, what may happen is that there were so many requests that the container that was available, that was handling the request, is already squeezed under the load. There's not enough resources on this particular EC2 instance where our container is running, so the new container needs to be spinned off to handle the additional load. So that's basically automatic scaling out to handle the increased load. And there may be any other reasons, because at the end of the day, we don't know how Amazon is handling this. So, and that is an important point, because we shouldn't really, rely on any deterministic behavior here. What about this? The second part, when the container is being destroyed. So again, it may be destroyed because it hasn't been used for some time, which means that your Lambda didn't have any requests. Right now, it's 10 minutes, right? For 10 minutes, if there was no request, the container will go down. But there may be another reasons. Obviously, the container might have failed because of some failure. The machine might have failed, or it may be unreachable because of the problem with the network. There may be the process of scaling down, because we just increased the peak of the load, and now the load is a little bit smaller, so we don't need too many containers, so we can basically destroy some of them. And again, there may be any other reasons that we are not aware of. So, if you think about this statelessness, it's not really that stateless. It's like you can accumulate some kind of a state, you can have some, for instance, caching. You can have your, I don't know, aggregate, having some changes after some comments that were invoked. But you shouldn't really rely on this state being persistent, at least not on the Lambda level, which is, if you think about that, which is basically the same what you have with the microservices, right? Because when you have the microservices and you have on the one part, you have this computational part, and then you have the storage, which is owned by the microservice. The rule of the thumb is that you should treat, there's the word for that, you should treat this computational part as ephemeral. So it may go down at any given point in time, especially if you are using Docker, Kubernetes, things like that. This particular node may go down and it may be started somewhere else in our cluster. Event-driven. Well, the event-driven means basically that it reacts to events. Those events may be external, so they may be some kind of a direct invocation of our Lambda, either from outside the Amazon infrastructure or within infrastructure, perhaps from different Lambda, or the Lambda may be invoked as a result of a certain event happening in one of these services. So you may think of it, for instance, I'm not sure how many of you how many of you is familiar with the Amazon services, but I'm just will describe at least in one sentence. For instance, S3 is used for storing files. So you may think about the event when you upload the file. It may result in an event invoking our computational logic within Lambda. You can have a simple notification service, which is basically a messaging queue that may end up in invoking our Lambda too. And then in the end, it's the computational part, as it said. It's the computational part of our infrastructure. So, sorry. One more thing, which is, I think it's interesting, because for many usages, that's actually a game changer. You are not getting charged by the fact that you have certain Lambda being configured and ready to work, like for instance in EC2. You are actually getting charged for the amount of processing that you will actually do. So the way how it works is that I'm not going to go into the details, but it's basically a sum of the number of invocations plus the total computing time times the amount of memory that you allocated for the particular Lambda. So I'm going to skip that and give you an example. If you have a Lambda which is consuming a little bit less than 400 megabytes of RAM, and that's the amount of RAM that you have for single request. I mean, you can have thousands of those requests, and each of them cannot exceed this around 400 megabytes. And each request takes, on average, 1 second. You would need to be somewhere below 1 to 10 million requests every month to start actually paying for something. Obviously, that's only for the Lambda, right? Because if you are using other services like databases, etc., other charges may apply. I'm only talking about the Lambda part. So to put this into perspective, if you take, for instance, the Imager service, which is the 38th on the Alexa popularity ranking in the worldwide, the number of images, for instance, that they have uploaded every month is 45 million, right? So it's kind of like a comparison. Obviously, they do a lot more things than only uploading images. So, the other question may be why Lambda and why serverless is reappearing now. Because if you think about that, some first attempts about that in that area has been started like 10 years ago and perhaps even before that. And I think that one of the reasons is that we started to have this understanding and technology connected to containers, Docker product, and things like that. And also we have the understanding and kind of a shared knowledge in the industry about the microservices, and basically, everyone is talking about the microservices these days. And it happens so that these are the lessons from the adopting of microservices at Netflix. It happens so that most of these points are really matching the way how we should create software in the serverless approach on AWS Lambda. Especially those 2 points are interesting because they match very much the approach of the AWS Lambda. And obviously that is not by accident. So last thing that would be worth to perhaps discuss before we go into the actual code is to think about what serverless is not. So there is also another name which is again a little bit unfortunate, which is function as a service. And many people think of it, okay, so we have a microservices, so serverless as a function as a service is even higher granularity, right? So it's like you don't have a service, which these days many people already are saying that microservice should be small. Some people are saying that it should be, I don't know, 1,000 lines of code or whatever, but that it should be relatively small, and that is even more granular kind of a component. I don't honestly think that that's the case, and many people are thinking about that, okay, what's going next? Well, would we have variables as a service, conditionals as a service, etc., etc.? I don't think that's the point, right? The point is that we can abstract away over certain things that related to infrastructure that proved to be common and very often not the core of the domain. What is the landscape? Well, it seems that we have more than one provider of the serverless services. The most popular one, obviously, is AWS Lambda, but we even have IBM here, right? That's Microsoft, and we even have IBM, which, interestingly enough, from these 4 products, only AWS Lambda supports anything related to JVM, and actually, interestingly enough, also IBM supports that because, as far as I know, they run on the Docker, so whatever you can put there, it will run. Google Cloud Functions, I think they only support JavaScript. Well, all of these products support JavaScript. This is the graph from I think 2.5 years. As you can see that AWS Lambda, comparing to the other providers, is definitely the most popular one. All right. So what is our timing? So here is the thing. My laptop is not, didn't want to cooperate with this projector. So I had some live demos, and I would need to skip that because I just, thanks to Gideon, I was able to present on his laptop. So I just brought some of the examples that I have into the slides, so we would need to stick to that. All right. So this is the simplest example built with the interfaces that are available from AWS for Lambda. So what's happening here? We need to extend a certain interface which defines a single method. And this method, as you can see, basically has 3 parameters. One is the input stream when we get our parameters into the Lambda. Then there's the output when we return the response. And then we have an interesting object, which is context, which contains a couple of interesting things. For once, it contains the logger, right? So we can log something. And it also has some other interesting parameters, not many of them, a handful. Like, for instance, this how many time in millisecond do we have before this request will be terminated? Because if it would take too long to generate the response, AWS will kill our handler. At least this processing of this request. And at the end of this, what we are doing is we are basically writing the response, which prints out the input, which puts the input again into the response. We get some unique identifier of the request, and here I am just printing the current date. That's basically it, the simple example. But that was the code. The question is, what do we need to do in order to make it work? Well, for AWS, what we need to do is to get our code packed in a jar and sent to Amazon. So we need to have something called Uber jar, basically jar together with all the dependencies. After we had this, we need to upload it to the S3. It's not strictly necessary in all the cases, but we may assume for the sake of this presentation that the general solution is to upload it to S3. Then, because Amazon tries to treat security seriously, we need to have a role which would be assumed by the Lambda, and the role needs to have some policies which will say what this Lambda is able to do. So the simplest Lambda needs to be able to, well, it doesn't really need to, but it's useful when it's able to write its own logs, right? So we can see what actually happens. Logs are stored in the CloudWatch service, so we need to be able to get the permission to write there. And then we need to have a function configuration which would assume this role, and when the container is started, it would grab our code from S3 bucket. Okay, how to do that? How many of you have an experience with AWS CLI? Oh, half of the audience, not that bad. So, for those of you who know what is the AWS CLI and how in general it works, probably that would be really easy. For everyone else, it doesn't really matter. Because the point here is that I wanted to show you that there are a couple of steps that you need to do, and later we'll optimize to show you that we can go away without all this dummy work that I will be doing here. So I need to have a single uber jar. What I'm doing, because I'm using SBT, I'm using Scala. So what I need to do is to have SBT assembly. That's one way of how you could create a jar together with all these dependencies. Here is my build SBT file. It's very, it's normal, right? It's nothing really related to Lambda itself, except I have these two dependencies, which are basically a set of interfaces, very small jars. And the other thing, again, not related to Lambda itself, that's related to assembly plugin, and I need to tell it what should happen in case I have a conflict when I put all the jars from all the classes from all the dependencies into a single jar. All right. So what I need to do is I have my project, which is called my module, which is called bear hello, and I am calling assembly, which generates the single jar. Then I am using AWS CLI to create a bucket. Well, I could reuse existing bucket, but just to show just for the completeness, I created new bucket, and in this bucket, into this bucket, I copied my generated Uber jar from my project. Okay, so we have code ready in Amazon infrastructure. What we need to create now is a role and policy. So first, we create role which can be assumed by Lambda. Then after that, I am attaching a certain policy. To be honest, this policy is wrong, actually. So I admit I cut a couple of corners there because, as you can see, this policy allows you to do everything with logs on CloudWatch. This is not something that you would like to do. You would like to allow your Lambda to change and modify only its own logs, not all the logs in CloudWatch. We'll fix that in a moment. I just use that because that policy is available as a default in Amazon. And then in the end, we need to configure a function, which is perhaps the most interesting part. Because, for the first thing, I'm picking the runtime, which is Java 8. I'm assigning the role that would be assumed, and I'm setting the timeout, which means that if the request comes to my Lambda, and it will, the processing of this request will take more than 10 seconds, it will automatically be killed. The other thing is that I need to set up the memory. This is maximum memory that can be consumed by a single request, RAM memory. So if we exceed that, again, the Lambda will be killed, at least this particular execution. There is an interesting point in that because there is no parameter saying how much resources in terms of computing power you would like to assign, because there is no explicit setting for that. It works like that. You can set a memory starting for, I think, 64 megabytes up to 1.5 gigabytes. And as you change this parameter, as the memory assigned to a Lambda grows, Amazon would also assign a bigger EC2 box for your Lambda. So if you get like 1.5 gigabytes for a single request, you will also get a very powerful box with more cores than if you set the very small amount of RAM. And the last thing is I need to specify the handler, which is basically the path to my method. That would be the entry point to my Lambda. All right. So Using AWS CLI, I can invoke my Lambda. That is the simplest invocation. And you can see that I just printed out what I had in my code. The input, empty, because I didn't pass any parameter. And I get the ID generated by AWS, and I get the time. Let's see how the client code could look like from the, how the client part could look like for client invocation from the code perspective. Well, the API is really, Java style. So how it works here is that you have a trait, and you have a couple of methods, which the name doesn't really matter. What matters is what parameters are you passing here and what are the return values. And those parameters would be passed to my Lambda. One thing that is interesting here is that I have two styles, actually three, but two important styles of the invocation. One is that this one would be blocking invocation, so I would wait till I get the reply. And this one is the event, which basically means fire and forget. So the event, I won't wait till the response will arrive. And this is the test that just connects to the Lambda. So you can see that, first of all, based on this trait that I created, I need to create a client. And from that client, I am using this hello method, which would be synchronous call. And I am using this other method, which would be asynchronous call. So I cannot show you the application, but I pasted how the execution looked like. So you can see that the first call, which is this one, would result in the result that we have here. And the second call, although I actually tried to get some result, will always result in no. There's no result because it's fire and forget. We don't have results. All right. That was relatively simple, but what if we want to have a REST? If we want to have a Lambda that would reply to some events, HTTP calls. So our diagram would be modified with this simple modification. The way how you deal with the HTTP on AWS is with the use of a service called API Gateway. Again, API Gateway needs certain permissions that would allow it to invoke a function. So to do that, we need to also, well, we don't need to, but the simplest way is to create a certain, such a case class, which would map into JSON with following fields, because if we do that, we would use the automatic integration with the API Gateway. So this is again a very similar handler. So we have the same set of parameters, nothing changed here. What's changed here is that instead of writing the response, I am actually serializing this object into JSON. So I'm setting only body, nothing else. And after that, I'm writing this response somewhere here into the output stream. All right. To make it work, I need to create a little bit more infrastructure, and this is lots of boilerplate that I need to do. As you can see, there is like multiple calls that I need to have in order to prepare the API gateway, and all this thing results, oh, it's barely visible, but you have only one resource, which is hello, which can reply to any HTTP method, post, get, etc., and call in response our Lambda. So there's lots of work for achieving this simple effect. Okay, so let's now see how we could make our life easier to avoid all this, plumbing to make it work. In other languages, like for instance, and in other environments like Node.js, it's pretty much it's much better because we have at least a couple of alternatives. We don't have that many alternatives for Scala. There is one project that I picked up a couple of months ago, and this project has been started by, well, that's the name of the project is, it's pronounced Quake. So the Quake is it's a drinking vessel, old school drinking vessel for whiskey, I believe. And it was started by these two guys, and I think that Brandon McAdams actually has a presentation about this micro framework on the Scala World 1 or 2 years ago. So what they did is basically they started this project, and they did some proof of concept. without many things. Many things were started, not many were finished and working. So I picked up at the point where they left, because they are probably busy with something else already. So and I picked when they left and started to experiment with that. So the whole idea is based on two components. One is the Quake, which is micro framework for handling, for helping us develop our Lambdas, and the other is Quartercask, which is SBT plugin. Right. So let's see how we can use those two things to actually deliver a Lambda, right? The working Lambda. So first, we need to have in our plugins SBT. We need to add our plugin, which is the Quartercask, and this is just a reminder what we need to create to our simplest Lambda to work. So if you look at this, for most of these things, there are concrete keys that are being added to the SBT that we can reuse, that we can use to configure how the Lambda should be deployed, right? Which role should be used, etc., etc. But I am really, advocate of trying to at least build a library or a framework in such a way so I could optimize for the developer's experience, and especially for my experience, right? So what I wanted to have is, I want to grab a code from the GitHub, and I want to build it with SBT, perform one command, and if I give it sufficient privileges, it should create everything that I need. I should be able to have running application in like minutes, maybe 2 minutes, not more than that. So I added the flag, which is create automatically, which is not something that you would use obviously in the production, but for the local development they're pretty good, or for any pet projects that you might do. And it works in such a way. This is again the SBT build configuration. It works in such a way that if I specify that, I can skip most of these parameters. And what I need to do, well, there are defaults, but I don't think I think you should specify these for your particular function. I specify the memory limit, the timeout, which is 30 seconds here, and this is one obligatory. I need to specify the region in which my Lambda would be deployed. So I use this option here, and there's two things that are a little bit of a boilerplate, mostly because I don't know how to get rid of them. I'm not that good with the SBT plugins, but it's work in progress. And what you need to do is create single class with this annotation, right? And when you have this annotation, you can take a look at this. There is nothing basically happening. I get a request, and I can write something as a response. So what I need to do to deploy my piece of logic now to Lambda is basically I'm calling for my module, I am calling deploy Lambda, and you can see here packaging. I'm going to create Uber jar with use of the SBT assembly, and I am inferring what is the name of what is the entry point. I can infer that based on this annotation. That is why I need it, and I inferred that this is the entry point for my Lambda. Then it's trying to figure out what the role should be. It sees that there is no plain sample role available, so it creates it. It gives it the minimal privileges that are needed to run my Lambda. And after that, it creates the bucket, because it sees that the bucket is not existing. It uploads my jar there, and that's it. Right? If you run it next time, it will just figure out that, for instance, here that role already exists, so it doesn't need to do anything. The bucket already exists, so if you change some code, it uploads the new version and updates the configuration of the Lambda itself in case you change something, like for instance, amount of memory. And that's it. After that, you can invoke your Lambda, and it will just work. If we take a look at some test. Here is the very, very simple test. What it basically does, it's again the same that we had before. Based on our trait, I have a client, and I invoke it 7 times in a row, and 8th time in an asynchronous way. And as a reminder, I'm showing you again how the code looks like. So you can see that we have the random value here, which is initiated when the Lambda starts. We have a mutable variable here, which is only to prove one of the points here. With each execution, I am changing it, adding basically 1, and I am executing my test. So 1, 2, 3, 4, 5, 6, 7 invocations, plus the last one asynchronous. The interesting thing that you can see here is that the random value is always the same. And the value that the variable that I was modifying is increasing. So we obviously see that, well, we have a state, right, which is being kept there, right? With each invocation, we see that there are the changes are visible, which brings us, perhaps, interesting idea what we could do, right? Because there is nothing stopping us, for instance, from, I don't know, having actor system there. Don't really pay too much into this sample because that's, I tried to do a simple actor with akka type, but I was having some experience with that in version, I think, 2.4.9 or 2.4 something, the last version from 2.4 or maybe 2.5.0, and it's changed a lot. So I was lost, basically, what should be done here. So my point here is that I have, again, Lambda, which on the start creates the actor system, and then on each event, I can basically invoke my actor system and pass some messages, do some interesting stuff. But that's really not really related to the Lambda itself. Let's see how with use of Quake we can use the HTTP, how we can handle HTTP requests. I will show this example on the, I will have an example with very simplistic Slack integration. So what I need to do is add another plugin, which is used for API gateway. That's another part of the quarter task. And what I'm doing here is, it's basically the same, nothing changed except this guy. I think that I should be able to use only this without this, which could be included, transitively via this plugin. But again, I'm not that good with SBT plugins. So, and this is how the code looks like. You see, we have another annotation which says that this is HTTP API, and we have here two methods. One is post, the second one is get. So I guess you can get the idea what it means. We have a post that would reply to the resource ping, and the body of this post would be string. And here I am replying to the get, right? And I'm just returning the text. So what I'm doing here, because if you have a command on Slack, how it works, it basically passes you several variables in, in a format that you have the key equals value and separated with ampersands. So I am basically, decrypting all this stuff and figuring out what is the username and printing back, great, it works, and the username. So how we would deploy this thing? Well, you have another task, which is deploy HTTP API. And it does these interesting things, which are interesting, and I will tell you why in a moment. And at the end, it tells you, all right, I just deployed your stuff under this link. You can just click it, and it's already there. So the demo, I needed to put it on the slide. It basically works like that. You have your comment, and you can run it, and it will reply with great. It works, Pawel Dolega, right? My username. The interesting points is one is the HTTP DSL that you already saw and that you've already seen a moment ago, and the other is the cloud formation, which I will tell you in a moment about. So HTTP DSL is basically, as you probably could infer from the sample that you had, we can basically set different different endpoints here that could be invoked. Different HTTP methods under different resources. We can have parameters, we can reuse those parameters, and basically you can easily create any kind of web application, right? That's one thing. The another thing is that this cloud formation. So the cloud formation is the idea, infrastructure as a code that you can actually express your Amazon infrastructure with a piece of JSON or a piece of, in my case, YAML. So what I'm doing here is that I am basically creating a REST API in API Gateway. I am creating a resource that will that would catch all the requests, and then I create any method. So this is basically everything that I needed to do from the AWS CLI, but now it's done automatically. With additional benefit, because I am using this to have to create this API gateway, but you could create anything with that. So there is anything related to, obviously, Amazon infrastructure. There is a project SBT CloudFormation, which is doing basically that. So you can have this, your infrastructure being a database, messaging queue, another Lambda configuration. It all could be put into this file, and I can from SBT say, okay, I want to my infrastructure, I don't know, I want to have another database, or I want to have another collection or table in Dynamo or whatever. So that's kind of comes from for free by using this. So where are we now? Basically, I am right now in the version 0.0.0 something, 4. And the thing that I wanted to pack into the first 0.1 version is to have a nice API for not only HTTP calls, but also for the direct Lambda calls, which could perhaps look something like that we would say that we handle event with this ID, and it would have it would be represented by this message, and we could do something as a response to that, which would be nice because we could have we could have a cooperation between different Lambdas. That's one thing. And the other, which should be relatively simple, this thing, is allow you to create any, web application, which I think is often the case for many, pet projects. What I could do is basically have a public directory. So normally what I'm doing right now with the SBT plugin is I'm just packing everything into jar and deploying in the infrastructure. What I could do is have a specialized folder and upload it to S3, and then using some kind of a directive of Lambda, whenever a browser actually asks to my resource that I would use as an index page, I would just send redirect to a web page or perhaps JavaScript or whatever I could have deployed on S3. So we can have a web application running easily here. Handling stacks, so this is CloudFormation, I already mentioned that. Interesting opportunities here to explore. And my minimizing is not that important. So the goal, like for the first version, is to have a kind of a tools that should allow you to create your pet project, whether it would be web page and a mobile, for instance, mobile backend for your application, backend for your mobile application, sorry. I mean, relatively easy, and you could grab basically clone the repository and deploy everything in 1 or 2 minutes, depending on the speed of your connection. All right, I think that's all. There are many other things that could be explored and that I didn't even touch. This presentation is available online. In case you missed that, whenever I made a mistake and I ended up in the slide that I didn't want it to end up, it meant that there was another path with the presentation, because right now we are at like 120 slides, something like that. There is like 40 more with different problems, with different things connected with the AWS Lambda, but you can see it online. I didn't manage to pack it into these 40 minutes. I guess, thank you. Do you have any questions?
Hi, thank you for your talk. I know that you said that this is not like meant for production, or that not that you're like advocating that this should be used in production already, but have you done, or do you know of anyone that has done like any benchmarks on like comparison like of the latency between like typically services in EC2 machines and this combination of the API gateway and the Lambdas?
But would it be, are you interested only in JVM-based Lambdas?
Yeah, that's...
I don't.
Okay.
But I can tell you, and that is one of my slides about the problems, that spinning up the container is terribly slow. I mean, it's like 7-8 seconds. If your container is down, to 8 seconds before it starts up and handles first request. Later on, it's relatively easy. I can handle most of the requests are in milliseconds, right? I don't think that it's that fast, because I think that's the case for most of the services in Amazon, right? That they are, as a single request, they are not that fast. They meant to be rather more scalable, right? So.
Anyway, I meant just like, in the long run, not so much like, the warm-up, not taking that into account, like whatever, if you need to spin up, like, assuming that your container never gets, like, you always get like a request at least within 10 minutes, like, so in that case, I was just wondering if you have any idea of, like, if there's impact in the latency or not.
No, I haven't seen such a comparison. I did see, though, extensive comparisons for Node.js. There's the guy, which is named, I don't know, his Twitter handle is, I think, Burning Monk, and he is doing lots of interesting stuff, but related to JavaScript on AWS Lambda, and has nice blog posts and metrics different that he grabbed from the production, because they are using in production, and not that in relatively big application, but they are using Node.js, right? And they have such information. I haven't seen anything for Java.
All right, thank you.
One thing is all those samples that I was meant to show you running are actually available in those repositories, this, and this. And if you export basically your, as an environment variable, your key for AWS, you would be able to just clone that and run all of this, I don't know, 30 seconds, something like that, and you would have working application with. For instance, Slackbot, right? Any other questions?
Yes. On serverless for Node, there is a serverless.yaml file. Is it not compatible with the JVM?
Sorry, say again. It was
on serverless for Node. There is a serverless.yaml file that does a lot of the thing you were doing as your plugin. Yep. Is it not compatible with the JVM? This serverless.yaml configuration file, which sets up all. So yeah, so on. I don't think you talk about it, but if you work with Node and serverless, there is a YAML file, a config file that sets up the whole.
But
thing.
you were talking about serverless.
Yeah.
Which, interestingly enough, I also have on my presentation, but I didn't show you that. That's very interesting because. I'm going to show you that just quickly, hopefully. Come on. What about hacking? That's way. I think it should be there somewhere. Yes. Right. The chalice is the Python version. And you can see, because that's whole idea about this HTTP DSL is taken from chalice. In Python, it works like that. You create the application, and then you create, you see this annotation, and that's your whole Lambda. You can do everything here. And your question, I think, is related to this, right? And here, what you do is, there's a very interesting project because it supports all those providers for serverless, but it works for many languages, but to be honest, its character is very much JavaScript-ish, something like that, so it doesn't really fit well into Java, but this is the file that you are mentioning, right?
Yes, that's correct.
So what they are doing is basically, you see those parameters that are basically the parameters that they use for the Lambda? They have this thing for the HTTP gateway. They mapped it kind of a one-to-one to this file, and they use it to create the infrastructure. And to answer your question, yes, you could have used that to deploy your application in Java. And even better, I have an example for that. An example is here. It's not here, it's here. But that's Java, so you can't see anything. But lots of stuff. That's basically Java code, and it's deployed from the serverless application. So it would work. It wouldn't be nice, but it should work, right?
Yeah, it could be scripted in the build pipeline. So, well, I mean, this could definitely be scripted, so we can have a bash script that will create a zip file and do this. So I thought it wasn't possible because you didn't talk about. This is why I was asking. Yeah. Thank you.
All right. Any more questions? Thank you for having me, and that will be all.